1A.3, scatter plots and regression models, is broken into 3 parts. We're going to start with part 1. Part 1 is about scatter plots, and parts 2 and 3 are about regression models, okay? And so that's what we're focusing on. When you came in, you should have picked up a half sheet. We all pick up the half sheet when we came in out of the basket. Remember, you come in, you get the work out of the green basket, or the bins next to it. So, bless you, bless you. Mm-hmm. Okay. No, this is our page. This is going to be page 7 in your handy dandy notebook. Okay. So starting off, we're going to discuss how scatter plots work, whether they're useful or not. I mean, they are useful because it gives you an idea of when you're trying to recognize a pattern, see what happens. You guys kind of got a little introduction dive into looking at scatter plots when you did, bless you, when you did your 1A.2, you are what you eat. You all remember creating a scatter plot, looking at it on your, bless you, on your calculator. So for each of the 8 scenarios below, identify whether a linear model would be an appropriate model for the data and explain your reasoning. So what you're going to go through is you're going to determine whether there's a type of correlation. So there are 4 types, well, 3 types of linear correlation. You have a positive linear correlation, a negative linear correlation, a constant linear correlation, or there's no linear correlation at all. Okay. So those are your 4 options: a positive linear, negative linear, constant linear, or no linear correlation. All right. What you're going to do at your table is we're going to give you a couple minutes to look at the 8 scatter plots, and then we're going to kind of quickly go over whether they are linear, non-linear, and go from there. So I'll model number 1 with you guys, and then I'm going to give y'all a couple minutes to do 2 through 8. Cool? So on number 1, I'm looking at this pattern right here, right? So as I look at these points, I'm asking myself, does this look like a linear relationship? And I can draw a linear line tracing out that linear relation. So when I look, I'm like, oh, this is pretty linear. Like a line would be a great model for this. I notice that it's increasing from left to right, which means that this is a positive linear model. Does that make sense? Okay. So that's what you're going to be doing at your table. You're going to be determining if 2, 3, 4, 5, 6, 7, 8 are linear models. All right. And then we'll quickly check. Allergies kicking your butt. I know that feeling. This is going to be page 7. You're writing on the paper and then you'll glue it to your journal. Yeah, the paper is yours to keep. So I'm going to put a couple minutes on the clock.
You only can use more than one shot.
You can use them multiple times. You can use them all multiple times. Yes. Huh? It's okay, you did. It's okay if you did. Timer kept going. It's okay if you did. It is okay. No judgment.
We're just waiting.
This week? Yes. Tell me my correlations. Is it linear, positive, linear, negative, linear constant?
Oh, it's like this.
I'm not.
Oh, scatter.
Linear, that's what you're determining. Linear positive. How much positive, linear constant, linear. You guys can talk to each other about it. If there's one you're really stuck on or confused about. Let your friends be helpful. Yeah, no, I did. You did all 8 of them? No. It appears upside down, but when you glue it in, it'll flip up. If it's no, then it's no. None of these are. Yeah, if it's no, then it's whether it's positive or negative. These are all. Wait. What's it's oh, our time is up. All right. Number 2, what do we get as a class? Here we go. Number 2. We say it with confidence. No correlation is not a linear correlation. That's because could I draw a linear line that's going to connect majority of my points or go through majority of my points? No, so it is not linear. No. No linear correlation. Okay, what about 3? What do we put? Good job, constant. Because the values are roughly staying in the same area. All right, 4. None. These are no correlation. Awesome. All right, let's flip it. 5. What do we say for 5? Good job. Positive linear. What about 6? No correlation. Can someone tell me what 6 looks like though? Like a parabola. Good job. Good job. Looks like a parabola over there. Okay. All right. What about 7? For the most part, I'll give it. If was it like a lot of extra right here? I could take positive. What about 8? Huh? Did you say almost? Oh, I thought you said almost. It is a positive. Does anyone remember what it's called for the points that kind of mess up your data? Oh. They're called outliers. So you have a couple of outliers, right, that would throw it off. But for the most part, overall, it's what? There is a positive linear correlation. Okay. So this is a useful tool for when we get to regression models. We have to start being comfortable identifying the shapes. Our 3 shapes that we've talked about are linear, quadratic, and exponential. If we go back to number 2 is actually a what model? It's an exponential. Number 2 was an example of an exponential model. Okay, so we need to be able to identify those shapes that we took notes over and be comfortable say, okay, well, this is the regression model that will best match what I'm doing. Okay. On the constant, as you get further into math, you'll realize that we're saying constant because they're like kind of within each other between 9 and 15, correct? So like it's a close range. As we get better and older in math, this is actually what we call a sinusoidal model. But we're not there yet. I just want to throw that little extra tidbit out there for you. It's a sinusoidal model. But for our knowledge level, we would say constant. All right. Okay. So the paper that you have, it looks like you're upside down, but you're not, because on the back you're gonna put a glue stick line, and then when you flip it in your notebook, it'll be, you get it? So it looks like, oh, she printed this wrong. I did not. I did it on purpose. Okay. There's intent right there. All right. So this is your page 7 reference of identifying. And now